Welcome to question 4 of the 2015 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAR. So for question 4 we're asked to consider the function f with a domain of -3 to 2 and a rule f of x equals a half multiplied by x cubed plus 3x squared minus 4. And for part A we're asked to find the coordinates of the stationary points of the function. And whenever we talk about stationary points, we want to solve the derivative f dashed of x equaling 0. So for this function, f dashed of x is going to equal, and the half is going to multiply the function. It would also multiply the derivative of the function, so we can just derive the three terms inside the bracket, and we would get 3x squared plus 6x, and then minus 4 would derive to 0. So that's the derivative, and we're going to set it equal to 0. So therefore, if we multiply both sides by a half, we really are just interested in 3x squared plus 6x being equal to 0. And as that's a quadratic, we can solve it by factorising out 3x as a highest common factor, leaving behind x plus 2, and that's going to equal 0. Now that it's factorised, we can use the null factor law, which would say 3x could equal 0, or that x plus 2 could equal 0. And solving those, we get x equals 0 from the first option, and x equals -2 from the second option. Now we need to remember that it's coordinates we were interested in, so we've got to evaluate f of x when x is 0, so f of 0 is going to give a half, and then inside the brackets we're just going to get 0 cubed is 0, plus 3 times 0 squared is 0, so we're just going to have minus 4, and a half times minus 4 just gives minus 2. And then we're going to evaluate f of -2, the other x value of a stationary point, and we get a half multiplied by, and -2 cubed is -8, and then 3 times -2 squared will give positive 12, and then we'll still have minus 4. So that is equal to a half multiplied by 0, which is simply 0. So therefore the coordinates are, and the first one we found was 0, -2, and the second one we found was -2, 0. So that is the answer to part A of this question. From the examiner's report, we can see that 62% of students got full marks for this question, with most students recognising the need to solve f dashed of x equaling 0. And some students incorrectly stated that the derivative was 3x times x plus 2, but technically we still needed a half out the front. And other students used the product rule to obtain a correct derivative, though this was not the most efficient method for the question. For part B, we still have the rule f, and this time it says f can also be expressed in a factorised form. So we're going to use that to help answer part B of this question, which says that we need to sketch on the axes below the graph of f, clearly indicating the axial intercepts and the turning points of the graph, and we need to label the endpoints with their coordinates. So first of all, from part A, we know that there's a stationary point at -2, 0 and at 0, -2. So I'm just going to mark those on with dots for our graph. And now using the factorised form, we can quickly see that x equals 1 is going to be an axial intercept of this graph. So we can put x equals 1 there. And now we need to think about the endpoints of this graph. So our first endpoint is when x is -3, and we can see that from the domain back up here. So f of -3 will be equal to a half, and I'm actually going to use the factorised form, so we're going to have -3 subtract 1 times -3 plus 2 squared. So that's going to give a half times -4 times, and this is going to be -1 squared is +1, so this is going to equal -2. So at -3 we have an endpoint at -2, which I'm going to do a coloured in dot there, because we have a square bracket in our domain which includes that point. Next we're going to find the endpoint when x is 2, and I'm going to substitute that again into the factorised form, although you could use the expanded form if you wanted. So this is going to be 2 subtract 1 multiplied by 2 plus 2 squared, which is equal to a half multiplied by, and the first bracket just gives 1, and the second bracket gives 4 squared is 16. So that's a half times 16 equals 8. So at 2, the graph is at 8, and that's a coloured in dot again. And now just for accuracy, we're going to find the function's value when x is -1, because we've got all the other function values on the grid lines between -3 and 2. So if we get this one, it will be a very accurate graph. So we're going to have a half, and then in the first bracket we'll have -1 subtract 1 times -1 plus 2 squared, which is equal to a half, and then that's going to be multiplied by -2 multiplied by +1, which equals -1. So we know it will go through this point here. So now our job is just to sketch a smooth and continuous curve through all these points, keeping in mind 2 of those points were stationary points, and then finishing at the end points. And now the only thing that's absolutely essential to label are the endpoints with their coordinates. So this endpoint had a value at -3, -2, and this endpoint was at +2, +8. And now because we needed to find all these other points, we can also label those with coordinates, although you didn't have to, but it might help to make sure that we've got them in the right spot. So this was -2, 0, this was 0, -2, and our x-intercept here was at 1, 0. So that is our final answer for this question, and the purple was, as I said before, optional for this particular question. So from the examiner's report, we can see that the question was generally well answered, with 54% of students receiving 2 marks for their graph. Students were generally wary of the restricted domain that was imposed in the question, although errors occurred with calculations or the placements of their endpoints on the graph. While labelling the intercepts and turning points was not required by this question, a correct graph was required to be awarded full marks. So you had to go through all the necessary points with the correct shape to get 2 out of 2 marks. For part C of this question, we're asked to find the average value of f over the interval 0 to 2. So we know that the average value is equal to 1 divided by b subtract a, so the length of the interval, and then we have that multiplying the definite integral between a and b of the function f of x dx. So for this question, the average value, so that average value will equal 1 subtract b take a, which is 2 subtract 0, and then we're multiplying by the integral between 0 and 2 of the function f, which has a rule of half, times x cubed plus 3x squared minus 4, and that's still with respect to x. And then this is going to equal, and the constant out the front is a half, and the constant inside the integrand can be taken out to combine with the other half to give a quarter, times the antiderivative, which is just now the antiderivative of the polynomial that's in the brackets. So we get x to the power of 4 over 4 when we add 1 to the power and divide by the new power. The next term will just be x cubed when we add 1 to the power and divide by the new power. And then minus 4 anti-differentiates to minus 4x, and that's going to be between 0 and 2. And then to evaluate that, we can have a quarter, and we can't forget that affects everything. And then we substitute in the upper terminal, which is going to be 2 to the power of 4 is 16 over 4, plus 2 cubed is 8, minus 4 times 2 is minus 8. And then we subtract away the antiderivative with 0 substituted in, and as a polynomial with x involved in all terms, that's just going to equal 0. And then this is going to equal a quarter multiplied by, and inside that bracket we just get 16 over 4 is 4, plus 8 minus 8 just leaves 4, so the average value is 1. And that is the answer to part C of this question. So from the examiner's report, we can see that 41% of students got full marks for this question, with most recalling the average value definition, which was not stated on the formula sheet. But then some did not integrate that correctly, which led to an incorrect answer. The main error in student responses was the misplacement of the half within the integrand. So that's this half here went missing somewhere in their working or went into the wrong spot. Some students split the integration, which was unnecessary and often done incorrectly. And some students confused average value with average rate of change, which is a common misconception in exams. And that meant that they found the gradient instead of the average value of the function.